shows that our data is of good quality. And this is the dispersion plot. This shows that dispersion decreases as the gene expression increases. And the heat map on the right shows that how similar the samples are. Each sample is mostly similar to itself, and importantly replicates from the same group are clustered well together. So this tells that our experiment is consistent. And this is the map plot. This shows the logfold changes across the genes, and the blue dots represents the most statistically significant genes, and we can see the widespread of changes or expression changes. And in the volcano plot we can see the upregulated genes, downregulated genes, and non-significant genes, and these are the topmost regulated genes which can be targets for our for the functional pathway and pathway analysis. And this is the Venn diagram showing the upregulated genes from day 1 to day 5 when compared to the day 0. And this is the heat map showing the top 100 variable genes. And this is the EMAP plot which shows the top 25 geoterms. And here we can see the abscisic acid signaling, defense response, and cell wall biogenesis and terpene synthase activity are all highly upregulated, and all these clusters are connected together. Here same genes are involved in more than one network. That means the plant is coordinating them together. And we can see in the geocircle plot, we can see terpenoid biosynthesis pathway is highly activated. That means the plant is producing more terpenoids as a defense mechanism. And here in this, this is the genes and enrichment analysis chart, which shows the most significant pathways. The plant cell wall organization is the most significant one here. The microtubular binding, microtubule based movement, microtubular motor activity are highly significant. Here it is showing that all the terms which are involved in the cell wall are highly upregulated. Here the plant is not involved in the growth metabolism. Everything which is needed for the cell wall, it is highly activating here. And this is the KEGG analysis bar plot. Here the phenyl propanoid biosynthesis, flavonoid biosynthesis, cutin and suberin biosynthesis are highly involved in this. These are the secondary metabolites which are involved in the defense pathway. So here we cannot see any growth pathways and photosynthesis pathways. Here after this is at the day 1. So here immediately within the 24 hours the plant transcriptional machinery is entirely shifted to the chemical defense. And this is the alpha linolenic acid metabolism, which is the most significant pathway. Here we can see phosphatidylglycolone processing is downregulated. That means the lipids are breaking down under the salt stress. And at the bottom we can see the jasmonic acid synthesis. That means at the end of this, the jasmonate is involved in the stress defense pathway. And these are my conclusions from day 0 to day 5, how the plant is responding to the stress and what are the genes involved and what are the main pathways involved. And these are the other supporting studies that I used in this. And these are the top 3 which are mostly relevant to my studies. And these are the references. And finally, I want to thank my committee members, staff members, and my professional colleagues, and my funding agencies, USDA, NIFA, and Evans and Grant. Thank you. I'm happy to take any questions. Yes.
My first question is, how did you implement the SARS test? At one side you were saying day 1 to day 5, but in the picture the plants were able to be. So how did you give the SARS test?
So after 30 days, I started giving the treatment. So at the 30th day, I started it as a day 0.
Okay. So how did you give the SARS test in the big pots?
In those big pots, I took the 100 ml of 300 millimolar NaCl and I directly give it to the root area, like near to the root.
Only near to the root
Yes.
Yeah.